Have you ever actually stopped to think about the sheer volume of invisible activity happening right beneath your fingertips? Every single time you interact with your device, you're kicking off this massive, perfectly orchestrated cascade of events. So today, in this explainer, we're uncovering the exact layers of your computer's tech stack. We're going to decipher how your hardware and software communicate at absolute lightning speed to make the incredibly complex feel, well, completely effortless. Here is our roadmap for today's explainer. We'll be looking at the two main types of software: the role of the operating system, utility programs, the hardware-software hierarchy, and finally, how interrupts actually work in real time. All right, let's dive straight into Section 1, the two types of software, or what we can call the surface layer. Whenever we talk about software, there's this fundamental divide: the software your computer needs to survive versus the software you need to actually get things done. To put this into perspective, think about a super simple physical action you perform, hundreds of times a day. What actually happens when you click a mouse? It feels completely instantaneous, right? You click and a window opens. Boom. But that single click acts as a catalyst, plunging us straight down through multiple layers of software. Keep that mouse click in the back of your mind, because it's a mystery we're going to resolve by the end of our journey today. So we've got these two distinct worlds of software. On one side, there's system software. This is your behind-the-scenes infrastructure. It controls and manages the computer hardware, basically providing a platform for everything else to run on. It runs continuously in the background from the very second you boot up. We're talking about your operating system, device drivers, and compilers. Now, on the flip side, we have application software. This is the stuff you interact with directly to perform specific tasks. You're the one who initiates it, like opening a word processor, firing up a spreadsheet, or launching your web browser. Essentially, system software interacts with a physical machine, while application software interacts with you through the operating system. Moving right along to Section 2, the operating system's role. It's basically the ultimate multitasking manager. You really have to think of the OS as the fundamental platform, bridging the gap between those user-facing applications and your physical hardware. As the source material points out, quote, "Without an OS, most computers would be user-unfriendly and nearly impossible for the average person to use." And it's true. Without it, you'd essentially have to speak to your machine in raw hardware commands. The OS provides the human-computer interface, or HCI. It acts as this invisible middleman, seamlessly translating your high-level clicks and keystrokes into the low-level processing power the hardware actually understands. And to truly appreciate just how hard this manager works, take a look at the 6 critical roles it has to juggle all at once. First up, memory management. It moves data between your RAM and storage, and absolutely crucially, it provides memory protection so two competing apps don't try to use the exact same memory location and crash your entire system. Then you've got security management, which ensures data integrity and handles your firewalls. It also manages hardware and peripherals using device drivers and data buffers. It handles file management, so all your directory structures and naming conventions. It masters multitasking by slicing up and allocating specific CPU time to different processes based on priority. And finally, user account management for customizing settings and access rights. I mean, it is an absolute powerhouse. Okay, Section 3, Utility Programs Explained. Think of this as the maintenance crew. If the operating system is the building manager, utility software is your highly specialized maintenance crew. Let's define this clearly. Utility software is a subcategory of system software, and it's designed specifically to perform maintenance tasks to manage and control computer resources. So, while the OS handles the big foundational stuff like memory and hardware, utilities step in with specialized tools to make sure the system runs securely and efficiently. They are the fine-tuners of your digital world. A really prime example of this is an antivirus checker. We all know malware, viruses, worms, ransomware, can easily corrupt the data stored on your computer. Well, an antivirus utility acts as your dedicated security staff. And it doesn't just scan for known threats. It uses what's called heuristic checking to actively identify suspicious behavior. It's literally watching for anomalies and quarantining infected files before they can compromise that vital operating system we just talked about. Up next, Section 4, the hardware-software hierarchy. Let's look at the tech stack. Right, so here is the complete tech stack required to run literally any application. Up at the top, at Step 1, you have your application software, the user tasks, like your games or web browsers. But remember, Those apps are completely depending on step 2, the operating system, which provides the environment for them to execute in the first place. Now, the OS itself relies on step 3, the firmware or BIOS. This is a small bootloader program, usually stored in non-volatile EEPROM, that handles the initial startup and provides low-level hardware control. And finally, this firmware runs directly on step 4, the physical hardware at the very bottom, the actual CPU, RAM, and storage doing the heavy lifting. Every single action you take trickles down this exact hierarchy. Which brings us to section 5, how interrupts actually work, the climax of the click. Okay, we know the tech stack, but how does it react to you in real time? Remember that mouse click we talked about earlier? Well, when you finally click that mouse, you are generating an interrupt. And an interrupt is exactly what it sounds like. It's a signal sent from a hardware device, or even software, directly to the microprocessor to demand its immediate attention. It quite literally forces the CPU to temporarily suspend whatever massive calculation it was doing, just to deal with your request. And the crazy thing is, your mouse click is just one single type of user interrupt. In reality, the CPU is constantly being bombarded by these signals. It could be a hardware fault, like a printer paper jam. It could be a software error, like an app attempting a mathematical impossibility, like dividing by 0, or two processes causing memory access conflicts. It could even be input-output processes, like a disk drive buffer emptying out and signaling the CPU for more data. Throw in timing signals, and it's a lot. To prevent total chaos, the CPU absolutely needs a flawless system to prioritize all these competing cries for help. So here is the incredible 4-step dance the CPU performs in a fraction of a millisecond every time it gets an interrupt. Step 1 is status saving. The CPU halts its current task and saves its exact status, specifically storing the contents of the program counter onto a memory stack. Step 2, priority check. It evaluates the interrupt. Is this mouse click more urgent than the background update you're running? If yes, it moves to step 3, ISR execution. The CPU loads the start address of a specific interrupt service routine, basically an interrupt handler, to deal with the click. Once the click is fully processed, we hit step 4, restoration. The CPU pulls the original status right back from the stack, and the previous task reinstates and resumes seamlessly, exactly from where it left off. It really is a breathtaking feat of micromanagement. By using interrupts, your OS maximizes CPU efficiency. It prevents the processor from sitting around idle waiting for slower hardware, and it creates the perfect illusion of flawless multitasking. So as we wrap up this explainer on the tech stack, I want to leave you with this final thought. Take a look at the device sitting in front of you right now. How many millions of interrupts has your CPU flawlessly saved, prioritized, executed, and restored just in the few minutes since we started talking? The invisible world inside your hardware is working tirelessly. And well, now you know exactly how.